So today we're going to cover Chapter 2, Section 4, and today we're going to talk about properties from algebra. So the first properties we're going to talk about are the properties of equality, and they're called the addition properties, subtraction, multiplication, and division properties. So for the addition, if A equals B and C equals D, then A plus C is equal to B plus D. So an example of the addition property where you were probably using it in your algebra classes is when they gave you a subtraction equation, and to solve this subtraction equation we needed to add the same number to both sides of the equal sign. So this is an example of subtraction property of equality. The addition property of equality, because we added the same number to both sides. For the subtraction property, what we're doing is subtracting the same number. So you would initially start out with an addition equation, and then we would use subtraction to solve it. So basically we're describing what we're doing here. Then for the multiplication property of equality, here is where if you have a division equation, let's say it's x over 2 equals 3, what we're doing here is multiplying both sides by the same number to solve, and we would get x equals 6. And then lastly, the division property, you'll be given a multiplication equation, and you're going to use division to solve it. So you would divide both sides by 2, and then this would be your division property of equality. So this is division, this one would be multiplication, subtraction, and then addition property. So basically you're just describing what you're using here to solve your equations. At the end of the multiplication and the division, this C with a equal sign with a slash through it, this just means that the number that you're multiplying both sides by can't be a 0, because 0 times anything is 0. And then the same thing on the division, we don't want to divide anything by 0, because when we do a division by 0, it's undefined. So that's why they have this little C cannot be equal to 0, because it won't make the problem make sense. So the next slide has some more properties of equality. The first one is the substitution property. And this one states that if A equals B, then either A or B may be substituted for the other in any equation or inequality. So for example, if 2A equals 10, then you could also say that 2B equals 10. We'll be using the substitution property a lot throughout our proofs. The next one is the reflexive property. And I see the word reflexive and I sort of think, oh, it sort of looks like the word reflection, because here what's happening is A equals A. So when you look in a mirror, you see yourself. So it's the same thing equals the same thing, even if it's a number. You could have like 5 equals 5. Now we'll also, coming up in the next couple slides, also apply these properties to the geometry, to our segments and our angles. Now, we'll be using the reflexive property when we get to the triangles and the quadrilaterals. So we'll be using this property then. For the symmetric property, think of it like a line of symmetry. So if you think about a butterfly, and if you were to take the butterfly and have it close up its wings, they would match perfectly, because we could draw a line of symmetry, say through the body of the butterfly, and then fold the wings to match them. So that's what a line of symmetry is. So here, my line of symmetry could go through the word then. And then I could match up, if I folded this on that line, I could say the B's match and then the A's match. So the symmetric property, it basically is saying the same thing, but it flips it. It sort of looks like commutative, but the commutative property is going to have an addition sign or a multiplication. This has an equal sign. So really you're just switching the order here. So the transitive property is another property that we'll use quite often in our proofs. This also sort of looks like the law of syllogism. So it looks like it. Because if you think about it, notice this B's, if A equals B and B equals C, then A equals C. So just like with the syllogism, these two B's are going to blend together or cancel out, and then you can conclude that the beginning equals the end. So then you could say that A equals C. So it's sort of like the law of syllogism. The distributive property, those are the last two. The only difference is if there's a plus sign in between the two numbers in the parentheses or the two variables, then it's the distributive property over addition or the sum, and then the other one's the difference. I don't need to see you write if it's a sum or a difference. Whenever you're describing distributive property to me, you can just write the word distributive. So another example that I could show you for transitive to show you how it overlaps. So an example of transitive could be if A equals 3 and 3 equals B, then you could say that A is equal to B because they're both equaling 3. So again, you see how the 3's would cancel out, and then you can go from the beginning to the end because they're both 3's. Now, these same properties that we just talked about, reflexive, symmetric, and transitive, we're now going to actually apply them also to angles and to segments. So over here are examples for segments under this column, and these are the examples for the angles. Remember, for reflexive, it's just the same thing equals the same thing. So you can, again, remember from chapter 1, when you name a segment, you don't need to necessarily put the picture of the segment on top of the capital letters, or you can. This is the only one that you don't need to have like a little label on top of it or in front of it. Now, last year when we covered this, and because some people we were taking our test on Canvas, it was kind of hard to use the equation editor. So instead of using the symbols, we would actually put the words in front like this. Now, because you're doing it on paper now, if you don't want to write the word angle, you can use the little symbol. And you could say angle D equals angle D. This is your reflexive. For the symmetric property, again, remember it's like a line of symmetry. So then if you were to fold it on top of that word then, the FG's would match, and so would the DE's. Same thing here with the angles. You could draw the word through the word then, and then everything would match. It's kind of hard to see because it's separated onto two lines. But again, same thing can apply to angles. I could go ahead, let's just do it this. So if angle A equals angle B, then you're just switching the order. Angle B equals angle A. And again, it's like the line of symmetry. The B's match and the A's match. And then the last one is the transitive. So again, see how the CDs overlap? And then you can conclude that AB equals EF. Same thing for the angles. Let me go ahead and draw the number line here to maybe demonstrate the segment here and how it overlaps. Let me go ahead and draw a little segment here. I'm going to add in the letters. And here's a B, a C, D, E, and then finally F. Okay, so given to me, I was told that AB, this piece from here to here, is equal to the CD. And then I was also given that CD, switch colors here, CD, this piece again, is equal to EF. Notice these two right here are the same segment, so they're equal to each other. So because you can show this as the overlap, and it's the same thing. And if this one was equal to this one, then this one's equal to this one. And you cancel out that overlap. And that's why AB equals EF. First example, they're asking us to identify which property is shown here. So if AB equals CD, then CD equals AB. This is the one where it's switched up. And again, you could look at it as like a line of symmetry here. And then the CDs match. And then the AB matches. So this would be your symmetric property of equality. Now, I don't need to see you add in the words property of equality. If you want to write that in there, you can. You could also abbreviate it as POE. Just be aware that maybe on a standardized test, they might add in property of equality at the end. But when you're doing this on the test next week, I'm okay with you just writing down the word symmetric. Okay, the next one.
Property of congruence.
So this is going to be symmetric property of equality. Coming up in the next lesson, we're going to talk about property of congruence. But right now we're just doing property of equality, and I just abbreviated that with an equal sign. But there's that also. What'll be different is instead of equal signs in it, they're going to have a congruent symbol. So the next one, all they did was distribute the 3 to the x and the y. So this is distributive property. And again, I don't need to see that you say that it's distributive of some. Just tell me distributive. The next one is substitution. And I'll show you what it means by that. So what they did was you were given that 2a plus b equals 24 and that b equaled 4a. So then what they did was they took out the b and they replaced it with 4a over here. So they substituted, took out b, and now replaced it with 4a. And this is substitution. And then the last one, they're asking us not what the original equation is, but what we used to solve this original equation. So the original equation is division. However, to solve it, we're multiplying both sides by 3, and that's how they got the 36. So this is the multiplication property of equality. And again, I'm okay with you not putting property of equality. You can just tell me multiplication. Okay, in this course, we're going to be writing proofs. The types of proofs that we're going to be writing are called two-column proofs. Now, this one's already given you all the steps it took to solve for x. What we need to do is give the reasons or explain what we did going from one step to the next. So just to show you, and I know there's not a lot of room, but this is how we'll set it up. Over here on the left, these are going to be called our statements. And over here, these are going to be our reasons why we put the steps in there. So the first step is going to be given to us. It's going to be the given problem that I'm asking you to solve. Now, when you're first doing these proofs, the algebra ones are going to be easy for you, but when we start the geometry proofs tomorrow, I'm not going to lie, it's going to be tough. Okay, some of you are going to get it right away. Some of you might not get it till Christmas. Some of you might not get it till next year after Christmas. It's going to take practice. Now, I noticed on the book that we've set up, or access to the online stuff, there is actually like a skills trainer. And I'll show you that maybe tomorrow, or if there's time at the end. I still have people that still need to set up their accounts, but they have practice on there that you can practice doing the proofs when we get to this. So, but the algebra proofs are going to be easy. When you're doing this on a test, do not leave off given. I want to see an attempt, because just by setting this up, the 2 columns, and writing in given, you get points. So don't leave that off. That's a freebie. Okay, so always start out by at least setting it up and then maybe attempting it, because you never know, your attempt might be correct. So here's what we're doing. They've already solved it for us. So what we're going to do is describe what is happening from step 1 to step 2. And it looks like what they did was they multiplied both sides by 3 to get from step 1 to step 2. So that reason is going to be multiplication. And again, this is the multiplication property of equality, but you don't need to put that. And that's my abbreviation for property of equality, POE. Next, we have to look and see what did they do to go from step 2 to step 3. And this looks like they distributed the 3. So that description or reason will be distributive property. And now from step 3 to step 4, it looks like they did the addition property of equality, because what they did was add 12 to both sides. So this would be addition. And again, property of equality. And then lastly, from step 4 to step 5, they divided both sides by 14, and this is the division property of equality. So basically, you're going to solve the algebraic equation, and you're going to basically, your reason will be the description. Okay, so again, POE, that's my abbreviation for property of equality. And again, I don't need to see that. You can just tell me multiplication, addition, division, but be aware of it, because in the next lesson, we're going to talk about property of congruence. And the only difference is they'll change it from an equal sign to a congruent symbol. And again, be aware of it, because you may see it on a PSAT or an SAT. But I'm okay with you, switching it up and just not putting that in there. Pretty good? All right, let's try another example. The next example, they didn't give you the steps. We're going to solve the whole thing ourselves. So again, I'm going to set up my 2 columns. I'm going to make a column for my statements, and then a column for my reasons. And again, do not leave off the easiest part of the proof of just writing down the problem that I'm asking you to solve. And this problem was given to you by me to solve. Now, this next step could be different depending on what you're choosing to move. You can either choose to move the letters together first or the numbers. So here, the addition and subtraction property can be switched up here. I'm going to go ahead and move my letters together first, and then I'll move my numbers secondly. Now, in the homework, when they give you, like the previous example where I gave you all the statements, sometimes they're going to add in another step called simplify. So let me just show you how you can add that like intermediate step, but you don't need it. You could just jump from the given to addition to subtraction to division, but I'm going to show you an intermediate step called simplify. So step number 2, I'm going to show that intermediate step, or I'm going to show you what I'm doing. I'm going to be adding 4x to both sides. So I have my original equation, and what I'm doing is I'm moving 4x to the other side by adding it to both sides. So I'm adding 4x to the left and the right. Adding it to the right here is causing this to cancel. It's making it disappear. But what I did was the addition property of equality. And again, POE. Now, the intermediate step would be simplify.
Wait, so you wouldn't have to specify what you're adding first?
No,
Oh, okay.
because if you move the two, you're going to be subtracting.
Oh, okay.
Does that make sense?
Yeah.
So now what I'm going to do is combine my like terms, and that's what it means to simplify. So I'm going to get 7x plus 2 equals 23. For my next step, step 4, I'm going to be doing the subtraction property of equality, because I'm going to subtract 2 from both sides. And this is subtraction. And now my next step, and again, if you don't want to show that in the steps, the blue stuff, you could jump right to what you got. So here, I'm going to get 7x equals 21, and that reason is simplify. Because what I did was combine like terms. And now my last step would be division. And again, you could do the same thing we just did. You could show 7x divided by, and then the 21 divided by 7. And this is going to be division. And then property of equality. And then you can finally say for the last step, x equals 3, and that would be simplify. Yes?
If we left out the simplify part, would you make it much long?
No. So that's what I would do. I wouldn't include the intermediate step, but I just wanted to show you in case you get it on a standardized test, they probably would include the simplify. But for my test, I would be okay. So if you want to leave it off, you could put this step, this one here, and then you could go to here, but then this reason is going to be addition. And then you could put this one, and then this reason instead of simplify would be subtraction. And then you could go from here to here, and then you would put division there. Does that make sense? But if it's better for you to see it, you can do that. Or you could do it like I did on the previous example and show what you're doing, but just not include it as a step. Try the next one. We're going to be solving for a variable and not solving to get a value for that variable. We're just going to rearrange the equation. Let's try the next one. So it wants us to solve for r. Given that p times the quantity of r plus 1 equals n. So again, let's set up our two columns. So we have our statements and we have our reasons. Again, number 1 is always going to be the equation that's given to you. And your reason is it's given. And now we're going to begin to try to get this r all by itself. So I need to move the p and the 1 away from it. So the first thing I'm going to do is distributive property. So I'm going to distribute the p, and I'm going to get PR plus P equals N. And what I did was distributed property. Next, I'm still working on getting R by itself. Now, again, I'm not doing the intermediate steps, but what I'm doing here is I'm going to be subtracting P. So my next step is just going to show the result of subtracting P. So if you wanted to include that as a step, then step 3's reason would be simplify. So here, this is going to be subtraction. And again, if you want to put POE, you can. And again, I'm trying to get R by itself. So remember, here's my R. Trying to isolate it. I got one more step to do. And it's being multiplied by P. So to undo that, I'm going to be dividing both sides by R. So step 4 is R equals, dividing both sides by P. So my final answer here is N minus P divided by P. And this is division. It's a lot easier maybe to just show yourself in color, or just show what you're doing to yourself, and then you don't have to show the intermediate steps of simplify. Good? All right, the last example is a preview of what's to come. So tonight's homework is just algebra. You will not have any geometry proofs, but the next example is a geometry proof, and it's what we're going to do tomorrow in section 2.5. So let me go ahead and just give you a little preview of the last example. But again, we've covered everything you need to do tonight's homework. It's just algebra. You're solving the equations and you're justifying each step. You'll also have to identify some properties just like we did in the first example. So let's go to this last example. It's going to be a geometry proof. We set up the geometry proofs the same way. So we'll make a column for statements, column for reasons, now this time the given information is from the diagram. Sometimes your given information is just going to be a sentence, and they might say given, they'll have a colon, and they're going to write down what's given to you. But for our given here, we're going to look into the diagram, and what's given to me is angle 1 is congruent to angle 3, and that's what I'm going to write as my first statement. So I'm going to say the measure of angle 1 is equal to the measure of angle 3, and that's given. Now, just to get an idea of where we need to get to, I'm also going to look at what they're asking me to prove. And they're asking me to prove or show that the measure of angle DBA equals the measure of EBC. So DBA is over here. Let me do it in a different color. I'll do it in blue. DBA is here, and they're asking me to figure out how that angle is equal to EBC. So this one over here. So what I need to try to establish is to get these angles into my proof. And I'm going to be using anything I've learned in chapter 1 and in chapter 2 to solve this or to show this. So what I want to do first is get the measure of DBA, these letters, into my proof. And what I can show is that the way that angle DBA is created, the blue one, is by adding the measure of angle 2 with the measure of angle 3. So I could say the measure of angle 3 plus the measure of angle 2 equals dBA. Now, I was also given in the first statement that angle 1 equals angle 3. So what I'm going to do is a substitution, and I'm going to plug in angle 1 here. So this statement, its reason is the angle addition postulate, because what I did was add the two little smaller angles, angle 2 and 3, and show that that's how angle dBA is made up. So this reason was the angle addition postulate. And again, if you want to abbreviate that as AAP, you can do that. Next, I'm going to do the substitution. So I'm going to take out the measure of angle 3, and I'm going to replace it with what it equals, which is the measure of angle 1. Everything else stayed the same. And this is called substitution. And again, if you want to say POE, you can.
Why should it plugging the measure of angle 1?
Because what I'm going to show you is that angle 1 plus angle 2 equals EBC. You see that? And then I can do a substitution again. So now I'm going to establish that angle 1, measure of angle 1 plus measure of angle 2 also equals the measure of EBC, which is the purple. And again, this is the angle addition postulate again. And I can call it AAP.
So would you have to add step 3?
Yes.
You have to
Addition angle plot.
Angle addition postulate. So it's the same reason as number 2. Now, the reason why I did it like this is I'm going to apply my transitive property, because if the measure of dBA equals 1 plus 2 and 1 plus 2 equals EBC, you see how these are going to overlap and blend together? So they sort of cancel out, and now you can conclude that the measure of dBA equals the measure of EBC because they both equal 1 plus 2. And this is the transitive property. Now, you could also, I would also accept substitution on this one. Either one. And that is your first introduction to a geometry proof. So again, as we're doing this, anything that we've learned is fair game as reasons in your proof. So when we get to chapter 10, you can use anything you learn in chapter 1 as a reason in a proof in chapter 10.